And I'm live. That is pretty cool. Yep, actually. And today is 4th of November 2025, Tuesday. And with that, let's just start solving questions. Shit. Yep. And okay, I messed up in the start itself. Okay. Yep. Stop the video and put poses. But before we start solving the 1600 rated questions, there were two questions which I messed up in a virtual contest, which I want to do right now. Yep, here. This was very bad. I mean, Code Forces was not giving any feedback for these questions while I was giving virtual contest because they were just in a queue. So yeah, and let's do these two first. Okay, I just didn't understand this question. What does this even mean? Uh, and this is, I would say, very complicated problem statement for our first question, right? Yeah, yeah. This was a bit more complicated than it should have been. Let a partition of multiset B be a collection of multisets S1 to Sk. Okay, so partition of a multiset B be a collection of subsets, multisets, such that each element appears the same number of times in B as across all S's. So we are just making partition of a multiset called B. For example, if this is a B, then this can be our multiset or partitions. This can be our partitions, or this could be, but not this. Makes sense. A partition is called valid if the mix of all the multisets in the partition is the same. The score of a valid partition is the mix of, okay, a partition is called, mm, okay, the score of any valid partition is the mix of any multiset in that partition. You are given a multiset A of size n. Find the minimum score over all valid partitions of A. I mean, why can the minimum score not be equal to 0 when we have something like 1, 0, 1, 2, 3? We can make this as one multiset, this as one, this as one, and this as one. Wait, there is also the thing about validity. A partition is called valid if the mix of all the elements in the partition of all the multisets in the partition is same. That makes sense. So mix would always be equal to 0 if there is no 0. And if there is a 0, then we will have to give the mix. Yeah, share. If there is a 0, then we will have to give whatever the mix is. Hello. You bro, just waiting for your stream, scrolling on your channel and focused on the video of your challenge. Shit. 1000 push-up. Ah, by the way, I saw the editorial of the problem at coder spec. Like I didn't understand why two pointers. It was like using three pointers. The truck problem. Yeah, it was using three pointers, and we could do it using one pointer and like a binary search, and not one binary search. We have to do two binary search because the number of B in the subsegment that we are considering limits the maximum size that the subsegment can be, and the number of A's in a subsegment limits the smallest size, right? So you find the smallest range from a current index, how far you can go and how minimum you can go, and that minimum range or like the interval in the middle, that will be your answer. Engage with your audience. What does this mean? Okay, members only stream. Shit. Yeah. And okay, now this one does make sense. What we have to do here. And yes, shit, I did something. Let me show you. Emacs. Kill server. There was not a server. Attach TCP. Target is competitive programming. And now here. Shit. Shit. It didn't run. Shit. Okay. Shit. Shit. Makes sense. My bad. My bad. Just 1 second. Let me fix this. Clear bash. uh, Makes so much sense. Okay. 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 I get the problem. Okay. I have written a script which will run whenever I start a new terminal session. But here, since whenever I start a new tmux session, the thing clears itself. Therefore, I must do send keys. Yeah, send keys. Target CP new m source dot this is RC. This should work. Tmux skill server. Tmux set start a new tmux session and tmux attach TCP. Okay, yes. Shit. A little mistake after sending in the keys, we have to press enter to actually start the command. My bad. Which is done by control M is the thing. I don't know why control M is the thing, but that is the thing. Kill server, tmux set, and this is like worth it. This is worth the wait. Look at this. Okay. Enter the result for 97 into 36. What is 97 into 36? Shit. Uh, 9, 2700, 2700, and 210, 2910 plus 9 into 60 or shit. 3600, 3600 as 90, 3510, 3500, 8, 3492. Let's see. Wait, processing might actually be him. So that was the correct answer. That was the correct answer. Nope, no headphones. 3900. Yes, let's go. Yes, 300, 3600 minus 108. Y- No, I didn't participate. They were testing out new question types, but no, I didn't. And yes, no headphones. And the plan today is first of all to just uh, do s- do these two questions, and there is a 1700 rated question which I was unable to do earlier, but I think I can do it now because in yesterday's stream we figured out a new method. Eric, Eric, our friend from Australia, he suggested a method for solving a 1600 rated question, and I think we can use the same thing to solve the 1700 rated question which we were facing difficulty in. So yeah, that would be nice. And for this question, shit, we have to start new room. My bad. And yes, okay, let me also show you this thing. Uh, I do not want to use my mouse and go there and click. So I can do window U. The button is clicked. Now I can do window 3 to go to the terminal and here enter. So I did this whole thing without touching the mouse. Like here I am just doing this from the keyboard. So that is like pretty cool. Window manager. Shit, I clicked on Discord. Short for opening Discord. My bad. Boiler. Wait, shit. I think I'm not. Yeah, shit. Competitive programming. Yeah. 2, U, 3, enter. Cool. Boilerplate, delete the whole thing. And then bool, there are equals false for and I equals 0, I less than n, I plus plus, vector int a size n, c in ai, and if not ai, if ai is not present, then zr equals 2. That is, there is a 0. Rest equals 0. But if zr, if there is a 0, then we will have to find the smallest number in a, the max of a. To sort a dot begin and a dot end, and for int I equals 0, I less than n, I plus plus. I will be equal to the max. So y I equals ai. We'll do I plus plus. I think that is okay. While I smaller than n. Still, not this. Int j equals I, and we will increase j. We will increase j. So when I equals 0, we will be, j will be equal to something that is one higher than I, and makes sense. Okay, makes sense. And if I is not equal to ai, or shit, I smaller than n, and ai equals max I plus plus. If we have a 0, then after this we will be pointing to something that is not a 0. Okay, if that is not the 0, if I is smaller than n and ai minus mx greater than 1, then not return mx, but rest equals mx, and break here, see out rest, see out rest mix. I think this is the right way to find the mix of a given range, right? Mix, right? But we also have to increase the mix. Mx equals ai. Seems okay, or maybe not. Shit, because I might go outside else if I is smaller than n. 0 is the only thing that is there. Makes so much sense. If 0 is the thing, then rest equals at least equals 1. Or shit, we can make a set, and the set will go forward. Bad English. Shit. Hello. Yeah. Another Vimotions in browser. I used them some time ago. Yeah, Vimotions are amazing in the browser. And this is not just Vim, this is something better. I am a CS student, but I don't know how to start my journey. Can you help me? Yep. Hello. Yeah, you can start with CSSP, I would say. This thing, you can take this thing and learn about a lot of very cool basic concepts, beginner friendly concepts, and have a good foundation, right? Depends on your goal. Did you aspire or save it from? Yes, of course. Inspired. Yes, it is inspired. It is not Technoblade. It is inspired by Technoblade. Okay, okay, shit. I am a retard. If zero does exist, then we have to find the max. Okay, now in this section, we just have to find the max. We have sorted A already, and we are saying max equals zero. Okay, and we start from the starting. While I is smaller than n and ai equals max, the current element is equal to the max. So that when we come here, we are pointing to the next element which is not equal to the max. Makes sense. And else mx equals or mx plus. That should have worked. That should have worked. Okay. While ai equals max, zr equals 0, y is res equal to 0, max else while I, okay, and if I is smaller than n, if ai is smaller than n and ai minus mx equals 1, that is, if this thing is okay, then we will increase our mx by 1, which makes sense. But if the difference is higher than this, then mx plus. And in here, if we are outside, then mx plus and break, I would say. Yeah, or we would automatically break because of the above for loop. Wait, shit, this should actually work. I equals 0, I is smaller than n is also okay. N is nice, A is nice, we are taking in A. If not A, ZR equals true, makes sense. And okay, if ZR equals true, we are going in here and then sort a dot begin, a dot end, right? I is smaller and ai is equal to ai is equal to mx I plus plus, right? We will, and everything in ai is 0, so and mx is also 0, so we will like keep going, and this part is the one which will exit, throw us out of this while loop. And when we are outside, we will check if I is smaller than n, which it would not be because we were thrown out because of this little statement. So we will go here and mx is equal to 0. So mx makes sense. Yeah, cool. Shit. Cool. Makes sense. And let's see. Yes, Vim motions. But shit, yes, on this screen, I do have to use the mouse, which is sad. Hello. No. Hello. How is everything going on? Nibleton builds. How do you solve these hard? Okay, this one. Okay, look at this. No, we do not solve these hard problems. We have to like shit. This is like problem number A, the first problem, which is supposed to be the easiest problem and wrong answer. And if you go to my rating is like this much, which is like kind of good, but I'm unable to solve this A problem, which is supposed to be very simple. So yes, yeah, yeah. Hello, I'm also fine. How are you? And shit, how are you guys like a single human being? Because this says one. That is crazy. I think I don't understand the question. If we here say that we have this one test case which has three numbers which are 0, 1, and 1. 2 is the output, makes sense. So why does it not make sense here? We are said to have the wrong answer on the fourth one. 1, 2, 3, 4. 0, 1, 0, 1, 0, 1. Compile one test case which has two numbers 0 and 1. Cool, cool, cool. Yes, shit, yes, cool. This works. S functionate. Huh? Okay, cool. Yeah. Yeah, okay. And for this one, this is the next question that we have to do. Shit. Pupil. Uh, Underrated thought. Yes. I mean, you can just start solving more questions and you will get better. Like, nothing can stop it from happening. If you are there every day, then yeah, you will get better. You can go to my previous streams if you want to. I would not suggest. And there I was a very big retard. I still am a retard, but it was way worse back then. Anyway, you can see that human beings can grow, even like stupid human beings like me can grow. So you can of course grow. And do we just have a single number? And yes, what we have to do is write a function is okay, which takes in a number and not just one number, but another number. And what this is going to do is whatever this n number is, if let's say n equals 5, the binary representation would be 0 and 0. And if k equals like 3, then this function will say, just by considering the lowest 3 bits, are they forming a palindrome? That is what this function will say is, yeah, let's call it is palindrome. Makes more sense. Yeah, and I got this wrong the first time and right now because earlier I realized after solving this that we have to keep increasing k's value from like the minimum number of bits that we have till as high as k can go, which is 32. Makes sense because yeah, 32 bits or 31 because this number n is a signed positive integer which takes up 31 bits. So that makes sense. Okay. Now for int I equals 0, I less than k by 2, I plus plus. And also one more thing, that this middle bit, this bit cannot be 1. That is something we have to keep in mind. So how do we get the ith bit and the ith bit from the end? For the start, let's say the starting bit would be n or we will make this a bool. S starting bit would be n bitwise and with 1 left shifted by I. Makes sense. And the ending bit would be and uh, bitwise and with 1 left shifted by, if you go k, then we will get the kth bit, which we do not want. The last bit is shit. The last bit is at index k minus 1, and we want the ith bit from the last, so k minus 1 minus I. K minus 1 minus I makes sense, I think. If I equals 0, then k minus 1, when and k equals 3, k minus 1 would be 2, 2 minus 0, 2, and 1 left shifted to the left by 2 times would land as 1, 2 here. So we will get that bit, which is nice. And both of them either have to be false or true. So if S not equal to E will return false. Like, yeah, on the spot, false. And return true at the end. And we also have to check if K is odd, then the middle bit, which is, yeah, if, yes, return. But if K is odd, then return the middle bit, 1 bitwise and with 1 left shifted by K by 2. This has to be false, like 0. This bit has to be off, only then the whole thing is true. Now we will find out the lowest 1 bit, which is on, and this whole arrangement. Yo, vibing. Okay, and K equals 0. So while 1 left shifted by K plus 1 is smaller than or equal to n, we will do K plus plus. Yeah, makes sense. So if we have 5, we are only increasing K by 1 if the next value is smaller than or equal to K. Makes sense, right? Now equals false initially, and for end, yeah, K, whatever K is, K less than 32, K plus plus. What we will do is P equals P or is parallel n when considering a different things. C out depending on P or no. At least should have worked here, and this is yes for the third last y, which is 8. 8 should not be, yes, 8 should not, 8 should not be yes, yes. This is 8 and we are looking at the middle thing. Just one test case, which is 8. Y is 8 equal to yes. See out P and space. We have this shit. We have this one test case. The number is 8, and that is crazy. P became equal to One test case 8 and k equals 3 does not make sense. Shit. Okay, shit, yes. Um, yeah, cool. Let's go. Because k is telling us how much do we have to go to the left. Yes, yeah, and k plus 1 would be the count of the bits that we are considering. So that is why we had to increase k by 1. Yep, does work. Okay, and shit, okay, I have to use the mouse. And again, I have to use the mouse. See, reverse Zor, let's go. Yo, we the range is 13. May be shit. Yes, makes sense. Makes there is no range on the initial number. Makes sense. There is no range on the initial two numbers or initial number which was reversed, and we took the XOR of the number. So that number can be as big as a long. So long. And here we will increase the range to go up to 64, and everything else checks out. And why is this integral? Is parallel P, or if P, then break just beforehand. And is parallel, N is long, which makes sense. And this question, okay, shit, since K can be very big, we have to make this one a long, and this also a long. And this one could also be a long. And now it seems to be okay. Okay, cool. Yes, that was the problem. Now, okay, and we can do more different questions. Why don't you give virtual contests? It is exciting. It is exciting. I mean, yes, I do give virtual contests, but not very thing. Oh, let's go. Let's go. I wrote it myself. No chat GPTing. Real. Yes, Bukowski. Charles Bukowski. Don't try and don't be afraid. And let's do. There was a question which was 1700 rated, and I was facing problem in that earlier, but now I think I can do this because yesterday we learned about a new formula from like one of the pro people who come in the chat, Mr. Eric. He told us about a formula that like if we are in an array at a particular index I and we want to know some information about some things from all the elements to the left of I, then either there is this method we can take a j which will go through all the elements on the left and find out that particular information that you want to find out, or and but this thing is slow because yeah, this is like n square time complexity, very bad, right? For every index we are going till the star. What we can do instead is we can keep a map or a separate array or something where we will keep this information that we are looking for. And when we are at a particular index I, we will be able to find that information directly, either in binary time or something. But we won't have to go through all the elements on the left. We would just be able to directly get that information. And when we have found that information on the left for this particular index I, then before moving on to the next index, we will add to our data structure ds the information related to this one, so that if this one is like the best match for some particular element later on, then we will be able to find this one from the data structure. That makes sense, I hope. Yep, I am on Discord. Yes, add me on code for so we can meet on the leaderboard. Shit. Blue ski. Wait, what? Blue sky? What is blue sky? Is something? Shit. Social media. Shit, bros on to too much social media. You can come on Discord. There's a Discord link, self promotion. Yes. Yeah, there's a Discord link in the same description that you liked a lot. And okay, let's do the question now. Yep. At the end, admin CF. What do you mean by admin CF? Like there is no name. I guess you have sent. Shit, don't use bad words. Be a good boy. Maximum. No, no. It was sum of all functions. Yep, this one. And this one is a cool question. Shit, okay, that is your name. It's the same as here on YouTube. Shit. Okay, why does it open here? Hmm. Let's go. And shit, you are online. That is nice. And now we are friends. And we will be able to stalk each other on leaderboard. And when did you start? You just started. That is fine. 2 weeks ago. Let's go. And yeah. And yeah, hopefully I give you a good impression of what code forces is and how you study or something. So that if 498 is much better than my first rating. In my first contest, I got 420. So this is much better. Okay, shit. Prodigy, child prodigy. Should solve. No, not on ad coders, just code forces. And shit, that is prodigy material right there. And you are friends of 3 people already. That is cool. And this question is the one that you are doing. Yes. Sad. How is it sad? Cool. Int n n, right, and then vector int a size n for int reference x and a, taken everything and shit. I messed up. BLSE, taken n and vector int a size n for int reference x and a, taken x, and now we have to calculate the answer, which is the XOR of all the elements in all of the ranges. Yep. and modulo this number. Yes. Okay, this is, we will go bit by bit, and first I will just try to write the answer, and then I will go through what I did, or like what I was trying to do. Okay, for and I equals 0, I less than 32, I plus plus, I less than 32, I plus plus, and yeah, less than 30. 10 power 5 numbers can be as big as 10 power 9, so I less than 30 makes sense. Now we will write a function, long, get, it will take in an integer I and a vector of integers reference A. And what this will do is find the answer. Since when we are taking XOR does not, XOR for a particular ith bit does not depend what is the bit on, like to the right of the bit that we are calculating the answer for, or to the left. So we can go in this thing bit by bit. And if our input vector is 1, 2, 3 or something, then if we write this in binary format, this would be 0, 1, 1, 1. And let's say then we start by solving for this first bit, bit at index 0. Then what we have to do is here in, we have to find out all of the segments which have odd number of ones in them, right? Or which we could say that the parity of ones, yeah, for how many indices is the parity of one different. Like for example, till this one, the parity of one is 1, which is odd. And here the parity of one is even, 0. The parity is different. And here the parity is again 1. Parity is just odd or even. So yeah, parity for this one and this one is same. So in this segment, the whole thing, we do not have odd number of ones, which makes sense. But the parity of the count of ones in this segment, where we are just considering these two elements, is different. At the ends of this segment is different. So that is nice. And that is what we have to calculate. And yeah, let's first of all try the hypothesis. If we have something like this, 1, 3, 2 makes sense. And yes, the switch between light and dark mode is kind of crazy. Hello, yep. But good that you are focusing on only one. Yes, I mean, if I get get good at one thing, then it will be very easy to switch between anything else, right? 1, 3, 2, 0, 1, 1, 1, 1, 0. And if we find all the segments in this range which have odd number of ones, this one, this singular segment, that is nice. This one singular segment, we can write, okay, the least bit has this pattern, right? This row, this like LSB, least significant bit row, has this pattern 110, and the next one has 011 pattern, right? Yes. And then here the number of segments which have odd number of ones is, there is one segment at the start, then there is another segment, the next one, and then there is one more segment which has a length of 2. And this one is one segment, this another one is another segment, and this is the third segment whose length is 2. And if we do the same thing here, we have one segment at the start with 0 and 1, that is one segment whose length is 2. and then the second segment with just the second one there, that is one segment, and the third segment is just the last one. And what we have to do after that is add all of these up. This turns out to be 4, and we also have to add all of this up. This also turns out to be 4, and the final answer would be this number that we calculated multiplied by, that is 4, multiplied by 2 raised to the power of which bit we are considering. This is the 0th bit, so 0 here, and this is the second or the first bit as at the like index 1. So this turns out to be 4, and this turns out to be 8, and the final answer is the sum of these two things, which is 4 plus 8, that is 12, and which is the correct answer. Yeah, 12. We just have to do this for the whole thing. Right, makes sense. Yo, let's go. Bye, and have an exam tomorrow. Data structures. Okay, let's study. You should study. Shit, IIT Guwahati. Long live IIT Guwahati. That is crazy. Okay, okay. For the ith bit, we have to calculate this above thing, this thing, and then we will go to the next bit and do this, and to the next bit and do this. Okay, okay, right. So segments, we have to find out the segments. Initially, we will say that the sum of the segments is 0. And we also have to say that when we are at a particular, go to Excel draw, right? In our vector, let's say we are at a particular index I, right? Makes sense. And we have a separate vector where let's call this pi is equal to the parity of all the elements, also where we are also considering this current element. So the range for this pi function would be starting till end. Both of them are inclusive, so makes sense. Okay, and we also have the pi for this I thing, right? P I for this, and what would be the range? Let's say 0, 0, 1, 0, 1, 0. Right. Here we will say if we see a 1, we'll say currently our C or P value for this thing would be equal to 0 initially. And whenever we see a 1, we will update the current value and make it equal to the opposite of the last value whenever we see a 1. So 0, we began with 0, we will keep it as 0. Here 0, we will not change anything, but here we see a 1, so we'll make this 1. Here we see a 0 again, so 1. Here we see a 1, so we'll make this 0, and here we see a 0, so this will become 0. Now ending at this thing, actually speaking, if we are not considering this thing, then the number of segments for which, and yes, to send the question again back on the chat. I've also started. Let's go. Right, that is cool. Just keep at it. Let's go. Here, the number of segments where the count of 1 is odd is this segment right here, and then this segment here. Makes sense, but if there was a 1 at some point, or yeah, let's just say this is the thing, and starting from or ending at this in this index, there is nothing. Here also nothing. There is this segment, and this segment. So when we are here, there are three segments. There are three segments which have this length, which end at this particular index. Makes sense, and the value here was equal to 1. So when the current value equals 1, then we have the current index. Yes, yes, current index. 1 means odd, 1 means odd, and yeah, this is odd, and shit. That is not stupid. That is okay. That is okay. Though. I thought we had just copied the above thing here at the down. So no, that is not what we have done. So that is cool. When we see a 0, we will go to the left and we will see the amount of ones. Yeah, we will see the amount of ones. What if we had one more one here? Then starting from here, this would be a range. This would also be a range. Okay, let's go for 1 0 1 1 0 1 0, and we are here. And if we make our second vector, where we start with 0 and we will keep 0. Whenever we see a 1, we will update the last value and flip it. 1 flip, 0 no flip, 1 flip, 0 no flip. So we are here, right? We are here, which means ending here from the start, ending here from the start, the number of ones is equal to 1. The number of ones is odd. Ending at this thing, the number of ones is odd. Makes sense. So how far can we take this? This is one thing which ends on this and this thing, and this is one, and then this is one, and this is one. These are the segments which end here. These are the segments which end here on this 0. How can we calculate that information from this? If we were to overlay these segments onto this would be one segment, this would be one segment, and then this would be one segment, and this would be one segment. These would be the 4 segments. And right. Okay, shit. So here, if we look at the pattern, we are seeing every time that we saw a 1. So whenever we saw a 1, we are considering that thing as part of this thing, and also this shit. We have to figure this out somehow or another. Shit, water. What we have to figure out is whenever we are 0 1 1 0 1 0 1, let's say, whenever we are at a index I, how many segments is this index the end of? How many segments end at this particular index where the count of 1 is odd in the segment? So this is one segment, right? And yes, the ranges are inclusive. Yep, that would be it. That would be kind of it. Yeah. So shit, if the current one is a one, what we need, shit, yes, if the current one is a one, then if the current one is a one, shit, some index, okay, for all the subsegments, shit. Yes, for this one, and this is one subsegment, this is another, this is another, this is another, and this is the last one, the longest one. And out of all of these subsegments, there are going to be which some segments, some subsegments in which the count of ones is odd, and the other ones, the leftover ones, in them the count of ones is going to be zero or is going to be even. So if we were to write that down here, the count of one is odd, here also odd, here even, here also even. Okay, there is also one more subsegment. We have taken this, we have considered this, we have considered this, but we haven't considered this one right here. And here the count is odd, here even again, and here even. So all of these are odds. This one, and this one are odd subsegments, and all the remaining ones are even. So for a particular one, if we do know the sum of sizes of the subsegments which have a sum, odd amount of ones and an even amount of ones, right? Let's say we know all of what we need to find out is the sum of size of this subsegment, this subsegment, this subsegment. Yeah, right. And if we know, let's say, sum of odd is something for this one, and sum of sizes of even subsegments is something for this one. Since this is a 1, this is a 1, and SE is the sum of subsegments which have even number of ones. So what are those subsegments? Those are which have an even number of ones, which would be this number itself, and then we have this one, and that is kind of it. 2. Yeah, 2. So these two are the only ones which could be extended onto this one to make the count of ones even, which is true. So if we extend this one to this, so this range has an odd number of ones, that is true. And this one also has an even number of ones, which is true. And one additional one, which is just this element itself. So that is also true. Hello, how is everything going on? And shit, this is the question from the other day, which we were doing at some point the other day. 1700 rated. Right, so that is cool. So shits, we can write a formula for SO and SE, sum of sizes of subsegments where the count of one is even and where the count of one is odd. And also do not forget that we are on a competition to reach 2000. Like we are still on the contest. If you are still onto it, we are there and we'll see who reaches 2000 first. Me, you, and there was the other person whose name was Hacker in the chat. We will see who reaches 2000 first. That is the contest. So if if a I equals 1, then SO and SE would be something, let's say previous SE plus 1 into the count. Yes, 1 into the count of even subsegments. Yes, and SE would be odd, odd subsegments. So SO previous plus count of SO previous. Or I think writing code would be much better than this. This one, right here. And this one is a pretty nice problem. We are going bit by bit and we are using like multiple different concepts into a single problem. This is a good question. This is actually a good question. Okay. Okay. Let's write a vector. We can make a vector to make things simpler. No. Long count some even some odd count even count odd, yeah, and some, yeah, let's substitute everything with nothing globally. Some E equals some O equals count even equals count O equals 0. Everything initially is equal to 0, and we'll say n equals a dot size, and for in I equals 0, I less than n, I plus plus. Initially everything is equal to 0, and if ai and if the current bit is 1 or not, 1 left shifted by I. Okay, let's call this thing k. K. Okay, if the current bit is on or off. If the current bit is on, then sum of odd segments would be sum, always say long current, yeah, current sum odd, current sum odd, yes, current sum odd, and current sum even. So here we'll say current sum odd would be equal to current sum. If the current bit is on, then current, then the count of all the subsegments, current sum odd, count of all the subs, not count, sum even, sum e plus cnt e, sum e plus cnt e, which makes sense, right? And not just this plus 1 for the current element itself, right? And current sum even would be equal to sum odd of all the things which have been plus count odd, odd, count odd. Okay, that is like actually pretty cool. Let's also take modulus. mod with M here also, mod with capital M, and yep, hello. The problem name is this one, sum of XOR functions, and my bad for white mode. So I've seen a friend's post. He has cheated in the past. I'm not sure if he was the same guy, which is in the team share. I don't remember the name. I mean, and you can go to the team and check it out. Shit, that would be actually crazy if someone is there cheating. Shit. And hello. Okay, we have current, sum, odd, current, sum, even. And I'm not explaining what these variables represent. My bad for that. But okay. And since now we also have to update rest plus equals current, sum, odd. That is what we want. And rest and yes. Okay. And how many segments end here, which how many segments end here for which the count of ones is odd. Since the current one is odd, then shit, now we need some extra variables. Current CNT odd and current CNT even. Current CNT odd would be equal to how many segments end here which have an odd amount of ones. That would be uh, CNT even plus 1. Now, yes, CNT even plus 1 because the current element itself singularly is also a segment, so plus 1 for that, and all the elements which were even, all the number of segments which had an even number of ones can be extended by one element to the right, and also take the current element which is a 1, and since they had an even number of ones till now they will have a odd number of ones. Makes sense. And current count even, how many have even? That would be current count odd. The last segment had CNTO, amount of segments which were ending here, there, which had an odd number or odd amount of ones. All of them can be extended by 1 and they will have a even amount of ones. So yeah, cool. We can say no, check. We cannot say this. That's it. After updating these values, we can say CNT even equals CCNT even. Yes. And CNT odd equals CNT odd. Yes, okay, cool. This is using like a lot of brain power, which I don't have in Access. Okay, we have updated all of the 4 variables if the current element is a 1, if the current bit is a 1. But if the current bit is not A1, if the current bit is A0, then sum of odd would be the sum of all the things, and they can be extended towards right by 1, right? Sum of odd, whatever the sum of odd was, and then CNP odd mod M. Okay, shit. Yeah, here we will say odd, even. We cannot directly update these values because they interdepend on each other. So we will here say CNT odd equals odd and CNT even equals even. And here also odd and even, even, and odd. Okay, odd otherwise would be equal to all the sub segments for which the sum has been odd. So sum odd, sum odd plus CNT odd modulus M and even would be equals to sum even plus ENT even. And shit. Okay, that is right. That is, we messed up here. We messed up here. Sum even. Okay, and if yes, sum even, sum even would be equal to even, and sum odd would be equal to odd. Makes sense. And how would the count of even and odd change? And yes, sum odd is the sum of sizes of all the subsegments which have an odd number of ones till now. Makes sense. And how are we going to update the count? The count of segments which have an odd number of ones would be count of segments which have had an odd number of 1 plus 1. No, no, all of them will just extend. Yeah, there will not be plus 1 here, but for count of even would just remain same, but count count of odd would remain same, but count of even would increase by 1 because this current segment in which we currently are is also an even segment, right? Makes sense. Okay, shit. Okay, okay, shit makes sense. And we will also have to write a function long, long mod mul, which takes in a long n and int I. Yeah, what this does is this will take n and left shift n by I amount, but also this will keep taking the modulus at each rotation to I. So for n j equals 0, j is smaller than equal to I, j plus plus, or we could say while I minus minus n left shifted by 1, yes, left shift n by 1 and take n mod by and at the end return n. Okay, almost there. Res plus equals res plus equals mod mul what long sum long sum equals the first function here get, which takes in k and a as the second thing. Uh, get I and a and sum equals or res plus equals mod mul given sum and left shift it by I time and this mod with m see out this. Okay, okay, shit. Off by, okay, this is a little lower than the actual answer, like all the time, a little lower than the actual answer. We'll see. We'll see. Something is wrong. Let's see. What is the sum for each iteration? Let's say we just have one test case, which, shit, my bad, that is not the format for the input. We have three numbers in our array, which are 1, 3, and 2, which is the first test case. Okay, 3 is wrong. 4 is correct, but 3 is wrong. 3 is wrong. 4 is correct. But yeah, 3 is wrong. 3 is not correct at all. The second number should be 4. So there is some mistake with this algorithm, and this thing should return 4 as we see here. Right. Makes sense. So yeah. See out sum e space will print everything and we will see or 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 what we can actually do as a like programmer is we can use LLDB and yeah, in G++ compile the name of the program, the name of the question, sum e with G flag, and we'll say out. Shit, out. LLDB out. Okay, cool. Breakpoint at main function and run, enter the password, and okay. Then next, next, it is now asking for input 3, next, next, and first number is 1, second is 3, then 2, right. Next, step into this, or no, we'll go to the next iteration. If we do frame variable, we will be able to see all the variables which are right now here. So we have a vector called A, where the first value is 1, second is 3, the third is 2, and we have a res variable whose value is 0 and I whose value is 0, and sum is equal to 4. Cool. Next mod sum, right? Let's see, and we can also do print, but that's, I think, yeah, print res or p res, yeah, p also works, to see that res is equal to 4. Cool. And we can enter s to step into this function, and we are inside the function get here, and we have res equals 0. Cool. Cool. Shit, why are we in else? Why are we in else? I think else is nice. The input is 1, 3, 2, which is 0, 1. Okay, so first thing is 0. Okay, then 1, 1, then 1, 0. These are the numbers. Cool, makes sense. And now we can begin. Yeah, frame variable. All the variables in the frame res equals 0, some e, some o, count e, count o, everything is equal to 0 and equals 3. And yeah, this would be equal to 0 makes sense, does it? No, it does not, because we messed up here. Yeah, that was the error, I would say. If we run now, okay, okay, and okay, let's go. The mistake was this: we were not updating the sum of even amount of segments. Okay, let's go. And before submitting, I want to see if there are some overflow errors. There might be some overflow errors, but I think we are avoiding them successfully. Yeah, this thing will never overflow, so that is nice. This thing could overflow, that is why we are taking modulus, and here also we are doing an addition, but this will not overflow. Here also we are doing addition, but not, this won't overflow. Cool. And yes, we have a separate function for multiplying with taking modulus. So that is nice. I think we are good to go. We can submit, actually. That would be nice. Let's see. If this is okay, then that would be like more than okay. Sums or function, and shit. This is supposed to be white theme. Let's go. Okay. And the time is also pretty cool. Let's now, since we have solved this, right, we are out of danger, we can play with this. Actually, we can play with this, and yeah, we can play with this. What is the time? 1 hour 23 minutes. That is nice. We can play with this. We can play with this. What can we do in our play? And yes, to go through what we have done. This is crazy, actually crazy, what we have done. Here we have a bunch of numbers, 1, 3, 2, and our main high level task is for every possible segment of any size. Like for in this array, for size 1, we have 3 segments. This is one segment, one sub-array is 3, and one sub-array is 2. For size equals 2, one sub-array is 1, 3, one sub-array is 3, 2. And for size equals 3, there is only one sub-array, 1, 3, and 2. And our task is Our task is for all of these subarrays, if we were to list them side by side, 1 is one subarray, 3 is another, and 2 is another, 1, 3, 3, 2, and 1, 3, 2. These are the subarrays, and our task, according to the question, is take XOR of all of the elements in this subarray and add that to the answer. So XOR for all of these elements would be 1. XOR for all of these elements would be 3. XOR here would be 2. And here XOR of 1 and 3. 1 is 0, 1, 3 is 1, 1, and 2, which will come on later, is this. So XOR of this element would be 2. XOR of these two would be 1. XOR of all of these three elements would be 0. No, no. XOR of these should actually 0. And if we add these together, we get 1 plus 1 plus 3, 4, 8, 9, which is wrong. Shit. The correct answer is 12. Okay, I messed up somewhere, somehow. I think we have to multiply this by the length also. Yeah, we have to multiply this by the length. Okay. So after finding the XOR, we have to multiply this by the length, which is 1. Here, length is 1. Here, length is 1. Here, length is 2. And here, length is 2. And here, well, length is 3, but this is 0. So, yeah. And here we'll be adding 1 plus 3 plus 2 plus 4 plus 2 plus 0 from there plus 0. And this thing turns out to be 4 plus 6, 10 plus 2, 12. 12, which is the actual answer. That is the thing. Hello, Eric. I'm very proud. We did this question that you were saying we should go bit by bit in this one the other day. And like I got the insight, you could call it, yesterday when we were doing the other question where we had to find subsegments of which had some particular property. And this question is like actually cool. I'm unable to fully comprehend this question as a whole. I'm only able to like think about this in parts as a like little story. But yeah, this question was good. And I guess in a few days I will be able to think about this question as a whole, like everything at once. So yeah, this is what we have. And what we can do is we can split this thing into bit by bit. That would mean if we were to write this as 0, 1, 1, 1, 1, 0, 0, 1, 1, 1, 1, 0. So for the subarray which had size 2, which is this one and this one, these two subarrays are of size 2. So what we want is 2 multiplied by the XOR of these two elements, which is 1, 0, plus the XOR of these two elements, which is 0, 1. What we can do here is go bit by bit, and we can say 2 multiplied by, for the first bit, 0 plus 1, right? Cool. Plus 2 multiplied by, for the second bit, 1 plus 1, 0 plus 0, 0. And this is equal to this because like that is how maths works. Yeah, counting from prefix, counting from prefix intervals, prefix intervals. Shit. What I did here is a sort of dynamic programming. I have the sum of all the sizes of the segments which have an even amount of ones, and the sum of sizes of all the segments which have an odd amount of ones, and the count of the segments which have an even amount of ones, and the size or count of all the segments which have a odd amount of ones. And one thing is that the count of even plus count of odd would be equal to all the possible segments till this current thing. And yeah, so we have initialized them, all of them, to be equal to 0. And if we see that the current number is a 1, current bit is a 1, yes, we are performing the whole operation on the A array at the kth bit. So if we are saying that for the ith element, this kth bit is on, then there is some way. The way is all sum of all the segments which had an even amount of 1, they can be extended by one element to include this current element. And since they had an even amount of ones, now they will have a odd amount of ones. So yeah, their sum earlier plus CNTE, because why CNTE? Because all of them are being extended by 1. So in total, we are extending the whole thing by CNTE count. Since there are CNTE amount of subsegments with amount of ones even, we are extending all of them by 1. So yeah, this makes sense. And plus 1 because the current element itself, just the single element itself with a segment size of 1 itself, is also a segment which has an odd amount of ones. So yeah, that is equal to odd, and even does not change, only the length changes. And we are updating these two things, and the odd number of segments increases by 1 plus to the even number of segments. And yeah, here we are equally, like, thoroughly updating when the current bit is off, and we are adding that to the rest and taking modulus. And yes, here, since we have to take a number and left shift that number by I amounts, and I can be as big as 31. Therefore, I have written this little function which shifts by 1, takes modulus, shifts by 1, takes modulus, and works like that. And this works because shifting is like multiplying, and we can multiply with modulus, but we cannot divide. For division, we have to take modulus inverse, but we can do multiplication and addition with modulus, so that is nice. And shit, this is a good question, not was. And yes, since we can split this thing bit by bit, and for calculating bit for a particular set of bits does not depend on whatever the other bits are. So we can go bit by bit, which is the exact thing that you said. So yeah, you helped in the part that we had to figure out. You helped by saying that you have to think bit by bit. So that was one thing. And then second is this concept. This is a new concept that if we are at a particular index I and we want some information about something onto the left of I, some index j, we want to find out some particular index j which matches I in some way, then instead of iterating through all of the elements onto the left, we can store the information of all the elements that we have gone through in some data structure, from which we can quickly gather whatever the information that we are gathering, which is also the thing that we do in longest common subsequence. When we are at a I, we are looking for the best j on the left, which can go with I, or the best j where a j is smaller than equals to a I, and the answer or response for j is the maximum response for all the j's where aj is smaller than ai, is smaller than or equal to ai. And that we can do in longest common subsequence by keeping a extra array of size n. N is the size of the whole vector where the first value is like minus in negative infinity and all the values are initially equal to plus infinity, and let's call this um, BS as in like best and not bullshit, and BS I would give us the smallest number AI which we require to have a length or to have a substring of length I onto the left for the current number. So yeah, that is like good. That is good. Yeah, this was a nice question. This was actually a nice question. Review. Yeah, cool. This was a good question actually. This is using a lot of different things at the same time. That is cool. Not shit, just it. 1600 rated questions. Let's go. Hello. How is everything going on? And yep, here let's do LSD. Oh, wait, it is LDS. LDS. Let's do LDS or lost soul. Lost soul. Okay, that is also something. Now stopwatch. Yes. Cool. And I will have to go to the washroom. I will be right back in just a minute. Yep. Just 1 minute. I'll be right back. And me totally back. All good, good. NumPy is crazy shit. I am watching from Chai and Code. Okay, let's go. Keep learning. NumPy is like actually cool. I guess I haven't used NumPy, but yeah, cool. Like creating your own model. His explanation is cool. Shit, I haven't watched his videos, but yeah, he's a nice person. He seems like a nice person. Pretty cool. And also, PewDiePie made his own model. PewDiePie AI. Uh, Stop using AI right now. Yes, he made his own model, which is like shit. Bro is going to take our job. He is like too much into this. Thanks for 15 years. Bro is actually too much into all of this. He's using Hyperland, he's using Linux and everything. Nah, that is crazy. That is actually kind of crazy. And let's go. Some LDS. Cool. You are given a permutation to PN such that maximum of the current element and the next one is greater than pi plus 2 for all of these numbers, which means the current element and then compute the sum of the length of the longest decreasing subsequence Okay. Okay, and this is a permutation. This is a permutation. We have numbers 1 to n. N is 500,000 at max. 3 to 1 sum is 10. 3 plus 2 plus 2. Compute the sum of the longest decreasing subsequence. The sum, what do they mean by the sum? Uh, Longest decreasing subsequence for any array. We define LDS as the length of the longest decreasing subsequence of A. In the first case, all decreasing subsequence such that every number on to the right is smaller. Three plus two plus one plus three. 3 plus 2 plus 1, 6 plus 3, 9. No, 10. How are they getting on to 10? Compute the sum of the compute the sum of the length of the longest decreasing subsequences of arrays. Okay, shit. That is a very good question. Then go tells everything in depth, like the internal workings of Python. That is very nice. That is very nice. That is what we need right now. Yeah, bro made his own AI ML. That is nice. PewDiePie. Shit. Shit, this is nice. And L and R can overlap. So 3 plus 2 plus 1. 6. Here 6 plus 3. Cool. 9. And then 9 plus 5, 14. 14 plus 6, 20. This should be 20. But why is this not 20? For any array in the first case, all subarrays are decreasing. The length, okay, we have to take the sum of the length. Take the sum of the length. Yes, length. Here, length is 1 plus 1 plus 1. Yes, 2 plus 2. 3 plus 2 plus 2, 7. 7 plus 3, 10. Okay, 10 makes sense. 10 makes sense for this. 1 plus 1 plus 1 plus 1 makes sense. And then for 2, highest length is 2. Okay, so already the answer was 4. 4 plus 2, 6 plus 2, 8. 8 plus 1, 9. And for the lengths of size 3, 9 plus 3, 12. And here plus 2, 12 plus 2, 14. And for this whole thing, plus 3, 17. Yeah, 14 plus 3, 17. Okay, shit, that is a nice question. That is a nice question. And why we have to take advantage of this fact somehow? We have to take advantage of this fact. This thing here means in our whole array, for any ith element which has two elements onto the left, one of those elements is bigger than this element. Mm, One of those elements is bigger than the other two. One of those elements is bigger than the other two. How can we take advantage of this fact. On to the left, one of the elements is bigger than the other two, which one of the elements is bigger than the other two. How does that help us? I think we can use something similar to what we did in this question, this behemoth of a question that we were doing just now. And we can say, but the problem with using that method is it is not taking convenience of the fact that this array is a permutation, and this fact that any ith element is going to be smaller than one of the elements towards its left, one of the two elements which are to its left. But let's see. Uh, for any ith element, what do we need? We need this ith element. There is this one subsegment, right? One subsegment here, one subsegment here, and yeah, all of these subsegments onto the left. We need to know what is the highest length. Shit, what is the longest decreasing subsequence in this range for all of these subsegments and add their length? Well, it would be the same as this one if it would be the same as this one if the number just here is smaller than this number, right? Right. If the number just here is smaller than the number here, because we won't be able to extend any of the things and include this current number into like any of the subsegments there. So there is like a break whenever we go uphill by one. Yeah, shit. If we make a graph of all of the numbers, let's take any example. Let's take this one. And if we make a graph of this thing, yeah, if we make a graph and yes, professional, one, two, that is not a very good graph. Two, three, four, five, and six. If we have a graph here, sh- okay, and we say that the first element is six, then we have a one, then we have a five, then we have a two, then we have a four, then we have a three. Shit, that is a zigzag thing. Decreasing subsequences are between the points where the graph is strictly decreasing. So this is a decreasing subsequence, and whenever a graph goes up, whenever a graph goes up, they are breaking points. We can treat this and this as a breaking point because this part is never going to be considered uh decreasing subsequence. So that makes sense. And so this is not going to be a part, and this is one thing. Yep, this is one decreasing subsequence, and this is not going to be a part. So shit, this is not going to be a part. So this is another decreasing subsequence. And since shit, now it makes sense. The first rule that okay, so let's say we have some pattern growing. And whenever we see a up increment, that is the next element is higher than the last element. Since this is a permutation, so we won't have straight lines, which we like seem to be having here. That is wrong. Since these are permutations, so no two elements are equal to each other. So let's say this thing goes down and down, and then at one point this goes up, which means the element at this location and the element at this location, this one second one is greater in value than this one. And can this go up twice? I think not, because that would mean this number is bigger than this and this number, which according to the rule is not possible. And the rule is maximum of a I and a I minus 1 is greater than a I plus 1. That is, maximum of this number and this number is always greater than the third number. So we cannot extend more than twice. Yes. I guess for sum of numbers, we use this. I mean, yes, we do use this. Right. We do use this, but we are not just calculating the sum of numbers. We are calculating for each subarray. Like this is one subarray, this is one subarray, this is one subarray, 3 elements from the start. This is another one, 4 elements from the start. This is another one, 5 elements from the start. And this is another one, 6 elements from the start. And then we can make this one the starting element. And now again, 1 element, 2 elements, 3 elements, and so on. And at the end, the final subarray would be just this 3. And in all of these subarrays, we have to find the maximum length of the subsequence, which is decreasing, and add that to our answer. So what we have been able to figure out is goes down, 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 and then goes up only once, not more than twice, not more than once, and then goes down, must go down, and then up, 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 or whatever. Okay. Okay. So what this means is when we are asking the question that we are at some ith element in this graph, let's say we are here and this element. Well, let's make a random graph. Goes up, down, 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 goes up, down, down, and then up. Cool. And this is 1 element, 1 element, 1 element, 1 element, and this is, let's call this a breaking point, and 1 and 1. And for this one, we are asking what is the length of the maximum decreasing subsequence, which clearly is this thing. And we know this because whenever we see this cutoff, this and this, we can divide. Yeah, whenever we see a cutoff, we can divide. We will not consider this edge, you might call this, in the input, and around this input we will cut off. And yeah, and this would be this. This has like 4 elements and this one has 2 elements. This is cut off, cut off, cut off, cut off. So yes, what is the information that we need? We need this best thing till now, and since here 4 is already the best thing, then this 2, we do not care about this 2, because for all the elements towards the right, this 2 will never be the length of the longest decreasing subsequence, because all of them will have this 4 as a part. Makes so much sense. Makes so much sense. So we can, at a particular thing, first we have to update the current running best sequence, and also the best possible length right now. We will see when we are at I, was the last element smaller? If the last element was smaller, if the last element was smaller, then we cannot increase the current length. So yeah, we will just make the current length equal to 0. Yeah. Which means current length, that is the longest decreasing subsequence, which shit, 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 shit. What we are calculating is not this. What we have to calculate is, starting from here, what is the best answer, longest decreasing subsequence in this range, in this range, in this range, in this range, and in this range, and then in this longest range. Shit, 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 shit. Yes, and shit, 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 shit. Yes, and we messed up, we messed up, we messed up. I think not. No, we didn't mess up. We didn't mess up. We can use dynamic programming here. Whatever the answer was for this thing, if we know the answer for this thing, we can know the answer for this thing. Yes, if for every index I, we will have two values. One would be, one would be, well, here we are going up. This I cannot extend anything. This I cannot extend anything. So answer for I would be exactly the answer for the last one plus 1 because of I. Answer of the last one plus 1 for I. Yes, answer for the last one plus 1 for I. Yes, answer for I minus 1, same, because I minus 1. Yes, answer for I minus 1 plus 1 makes sense. Okay. But if I was also decreasing, let's say like this, and I equals this thing here, and these are the elements, then this I will be extending a few things. This is one range, so we will always add 1 to the previous thing. But this is one range, this is another, and then this is another. And we have to add for this one, this consider this range, this range, this range, and this range. And out of these four ranges, this, this, and this. They were continuously decreasing. And for I, all of these ranges can increase by 1. So longest increasing subsequence, which has been till now. But what if adding I changes the longest increasing subsequence? We are getting somewhere. We are getting somewhere. We will be able to solve this. And yes, this is a good question. Okay. Graph. Let's take this answer is 40. The graph would be totally up, as low as can be, high, low. This is 2, then 4, and then 3. This is the thing. Okay. So when we are here, we'll have another vector. These are the points, the elements we have. This is one element, this is one element, this is one element, and this is one element. Okay. For this, the sum of, yeah, the answer for the array to the left here would be 1. This is dynamic programming. This is dynamic programming. 1. And yeah, answer here would be 1. And for this one, what do we need? For this one, we are considering two lengths. Uh, one thing is just this, and the other length will be this, for which we have to see is the current element is smaller than the last one. And here it is. So the longest length for the longest decreasing subsequence length would increase by 1 if we add this number here. Let's make two vectors. Let's make two vectors. Yes, one vector would be the answer. Here we'll call this one dp, and another would be what is the longest increasing subsequence in this range. Yep. Let's say 6 1 6 1 5 2 4 3. This was our thing. Okay. 6 1, the longest decreasing subsequence length is 1. Here it is 2, which ends at, which not ends, but yeah, towards the left of this thing. Here answer would be 2 towards the left. Yeah, yep, it would always be now 2. Not 2. Not, yes, 2. 2. 2 is okay. 2 is okay. 2 is okay. Yes, 2 is okay. This would be 1 plus 2. I for AI. What would be DPI? DPI, depending on AI, if I equals 0, DPI would be 1. If I is not equal to 0, that is, there is something on to the left of I, then we will have to see. If I is not equal to 0 and AI current element is greater than the last element, AI minus 1, current element is greater than the last element, then answer would be DPI minus 1 plus 1. DPI minus 1 plus 1. Cool. But if not, if I is not equal to 0 and AI, the current element is smaller than the last element, AI minus 1. If the current element is smaller than the last element, yes, if the current element is smaller than the last element, which means the longest subsequence which ended at the last element would have to be increased. The longest subsequence which ended at the last element, that is AI minus 1, can be increased by 1. And what would that longest increasing subsequence be? We can make longest decreasing subsequence I minus 1. That would be the length. Yeah, which ends here, whatever it is. This thing, we will find out this thing and we will add 1 to this. Makes sense. So now, for all all of the sequence for all of the sub segments which are inside this longest subsegment, the answer is 1 plus 2 plus 3 plus dot 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 till L D S I minus 1 plus 1. Yes, and for all the sub since we are here at the ith element here, and we are saying L D L D S plus 1 is the longest increasing subsequence which decreasing subsequence which ends here at I. Let's say it is this long, right? So for all of this interval, the answer would be this much contribution to the total response. And for this, when we are extending our range towards the left, right, till here, then we will have to see what is the best answer. Yeah, then we will have to see what is the best answer. If this is x and since we are unable to go past this, that means here there is a break. The element here is smaller than the element here. So yeah, there is a break here. So if we go x till x more towards left, we will keep adding x. But beyond that, there is a possibility that the longest decreasing subsequence is has a length greater than x. or x could be greater if shit, this is a bit complicated. This is a bit more complicated. Okay, but I do not want to leave this. This is a good question. Uh, Subsequences. Shit, I'm really bad at subsequences. Subsequences and like two pointers and stuff like that. It has been 2 hours and 10 minutes, and I'm looking forward to end. But no, 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 no. The question is this, which is a nice question. So 9,000 people have been able to solve this. That is a lot of people. 30 minutes. What can we do here? 1 plus 2 plus 3, and that makes sense for that whole range if we are extending, then the answer is correct. And now depending, and now there is a cut at this point, and the answer here can be calculated independently from this part. Okay, okay, and even for this cut part, x is the best answer, and all the things tell x more indices to the left. X is going to be the best answer, but then the answer could change. Depending on what is the longest increasing subsequence in that range. If x is longest decreasing subsequence in all of the ranges, all of the ranges. No, since we can divide, if you look at the graph, since we can divide this graph, whenever we go up here, this is a long increasing subsequence, decreasing subsequence. This is also a decreasing subsequence. Since we can divide, yeah, it is easy to know these decreasing subsequences. We do know the answer for all of the segments in this range, which would just be this sequence. That is nice. we have to ask how much can we extend this towards the left and how much can we extend this towards the right. That does not seem to be the right way because depending on where we are on the left, we will be at different places on the right. So yeah, that is not a right thing to do. I think index by index is the way to go. For a particular index I, what is the best answer for all of the ranges? This where yes. What is the longest decreasing subsequence in all of these ranges? These questions are tough. 1600 is 1600 makes sense. Tough. It's nice. Mm. If there is this like cut, right? We are not increasing the answer by any amount. So here the answer would be just the answer for the previous index plus one. Yeah, plus one. But if the current element is smaller than the last element, that is where we have to think. That is where we have to think. We can see how many things this is increasing the answer for. That makes sense. But then before that, this would break whenever either we end or either we have reached the start or the element where we ended is greater than the last element. And this is a permutation. Can we go over this in like a totally different manner? Maybe in by the number of invariances that we see 6, 1, 5, 2, 4, 3. Here we have an increase here, and that is it. Yes. No, I don't think number of invariances is going to do something. It could, I don't know. Here, okay. So the problem here is we have a new longest decreasing subsequence, and that might change the answer for everything that we have seen till now. Shit, shit, shit. We know the answer for I minus 1. We know the answer for I minus 1. We know the answer. We need to know the answer for I. If I is smaller than I minus 1, I increases this. Yes. And we can also have what is the best longest increasing subsequence for I minus 1. Right. And shit. And the current longest increasing subsequence, longest decreasing subsequence, not subsequence, segment, longest decreasing segment, which ends at which ends at I. If this thing and also longest decreasing subsequence at I minus 1, which not ends at I minus 1, but not just ends at I minus 1, but is like towards the left of I minus 1, wherever it is. Yeah, does not matter. And also, which ends at I minus 1. Longest for the current one would be 1 plus LDS I minus 1 plus 1 if the current number is smaller than the last number. Okay, and this is the longest length of the subsequence, longest decreasing subsequence length, subsegment length, which ends at I. Okay, that makes sense. And that makes sense. And if LDS I minus 1 is the longest decreasing subsequence which ends at I minus 1, but let's say LLDS I minus 1 would be longest decreasing subsequence which is to the left of I minus 1. It might not end at I minus 1, but it is towards the left of I minus 1. And if this thing is greater, if this thing is greater than, if this thing is greater than the current answer, then the current LDSI, which we just calculated, then current DPI would be equal to DPI plus DPI minus 1 plus LDSI plus LDSI plus LDSI. Yes, but if LLDSI minus 1 is smaller than LDS longest decreasing subsequence which ends at I, if that is greater than longest decreasing subsequence to the left of I minus 1, then and it can only be greater by one. Right? Yeah, it will not be greater by like 5. So it will the answer will only be greater by 1. And we will in this case have dpi equals dpp, not pp. We will have dpi equals dpi minus 1 plus I plus 1. Shit. That is the hypothesis. Shit. This might actually work. Try to get this right. Int n p n n. How is the input? Okay. vector in A size n for intersection x in A, C in X, everything is filled. Long. Rest we will find out later. We need three vectors of integers. One is dp, size n. One is LLDS, size n. And one is LDS, size n. And now we need to initialize. dp 0 equals 1. dp 0 equals dp LLDS. Why did dp LLDS? LLDS 0 equals LDS 0 equals 1. And then we'll start iterating for in I equals 1, I less than n, I plus plus. And now depending if ai, the current element, is greater, let's say, than ai minus 1. If the current element is greater than I minus 1, then dp I equals to dp I minus 1 plus 1. Yes. And also, not here, but here, dp I mod with m. M does not exist right now. M is, here we are not taking modulus of anything with anything. Okay, we are not taking modulus somehow, which makes sense. Yeah, and we don't need to take modulus because the maximum answer can be n into n minus 1 divided by 2. And we have that maximum value of n is 5e5. Yeah, so that is nice. And now the else part. If we are extending the length, and also shit, we also have to update in this case also. LDS I equals 1. The longest length of the subsegment which ends at I, LLDS I equals LLDS I minus 1. That is to the left of I. Now, if we are extending, then LLDS I equals LLDS I minus 1 plus 1. Cool. Yes. And dp I equals dp I minus 1. Now we have to add some values to this. And also let's update LDS. No, this is LLDS, not LLDS. LLDS I equals maximum of LLDS I minus 1, comma LDS I. Okay. We will first of all do plus LDS I plus equals LDS I. All of those subsegments are being increased by 1 plus 1 extra subsegment which is just this ith element. And I'm being like very vague with what I'm doing, but I think I'm doing the right thing, at least in this. dpi plus equals LDS I makes sense. That is correct. But also if LDS I, the longest increasing decreasing segment which ends at I, where I is the last index. If this is greater than LDS I minus 1, that is the longest decreasing subsequence or longest decreasing sequence which does not end but is in the range 0 to I minus 1 inclusive. If the current one is better than all of them, so dp I plus equals here if greater. We will add to our dp plus equals I plus 1. Okay. I think that is very genius. Okay. I think that might actually work. And now at the end, the answer would be accumulate dp dot begin and dp dot end comma 0 cout. Okay. We will see. Okay. Phase. Yeah. Okay. What's that? Amazing. Cool. Okay. Shit. We are feeling here. Why are we feeling here? LLDS, LDS, LSD would have been better, but anyway, uh, compile just one test case which has 6 numbers: 6, 1, 5, 2, 4, 3, 1, 2, 1, 2, 1, 2. Amazing. Yes, cool. Why is the answer 30? Let's also output the DP table. 6 numbers. Okay. Uh, we have just one test case which has 6 numbers: 6, 1, 5, 2, 4, 3. Okay, DP is that okay? For the first one, answer is correct. For the second one, answer is correct. For the second one, for like 5, for this place, answer 4 is correct, absolutely correct. And then yes, because in this range, answer is 1. In this range, answer is 1. And then in this range, answer is 2. So 1 plus 1 plus 2, 4. Cool. For 2, we are in this range 1 plus 2, that is 3. Here also, let's go. Let's go. Es funktioniert und ich bin glücklich. Okay, this is working. Let's, what you have to do now is we will delete this whole thing before submitting and we'll write from scratch. Take an n and vector in a size n for in reference x, x in a, c in x, and now we need 3 vectors, dp size n and lds size n and lLDS also size n. What do we have? Yeah, let's say dp I is answer for range 0 to I. both are included. And LDSI is longest decreasing longest decreasing segment ending at I. Yep. LLDS, longest decreasing segment in range 0 to I. Okay, okay. And let's say, yeah, now we have to initialize. DP 0 equals LDS 0 equals LLDS 0 equals 1. Why all of them are equal to 1? Because answer for a single element is equal to 1, and longest decreasing segment ending at a element is 1 if we are only considering that element, and also in the left in that range answer would be 1 because we don't have anything else. Then we will start calculating from 1 I less than n and I plus plus. Okay, and now depending if ai is if ai is greater than ai minus 1. If the current element is greater than the last element, then we know dp I equals dp I minus 1 plus 1. LDS I equals 1 and LLDS I equals LLDS I minus 1. Why does this work? Yeah, this works because if the current element is greater than the last element, then we cannot increase any of the ranges which we considered for the I minus 1 element, if that makes sense. But if that is not the case, then we will be able to increase some ranges. And let's update longest sequence which ends at the current element would be longest sequence which ends at the last element plus 1, because we can extend that one by one element because the current one is smaller than the last one. And LLDS I would be maximum of LLDS I minus 1, which was ending at the last one, and LDS I. Cool. Okay. And now dp I equals dp I minus 1. Why? Because answer is at least what was the answer for the last segment, and we have to see how many of those segments we can increase by 1. Yes, how many of those segments we can increase by 1, which depends on if LDSI, the longest decreasing subsequence, which ends at which ends at this current number, if that is greater than or equal to LLDS I minus 1, then we can increase all of those subsegments by 1, and in total there are I plus 1 subsegments onto the left. So I dpi plus equals I plus 1. If that is not the case, then only the subsegments in this LDS I range are going to be increased by one element. So LDS plus equals LDS I. I think that is actually okay. Increment by 1 and by no 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 dpi plus equals LDS I, that will be 1 increase plus 2 plus 2. Shit, that makes sense. Now, if this is the case, and okay, laptop is going to die, but the phone, shit, actually going to die. We are almost pretty good. Okay. If LDS I 2 minus I greater than 1, LDSI is the longest decreasing subsequence which ends at I, and I is the number of elements which are on the left in the whole array. And if there are extra elements left, then we will do LDS or DPI plus plus. And if the element is the last, then okay. Long rest equals accumulate dp dot begin and dp dot end and see out rest. Okay, okay, it is working. I think this would still work if we remove this line or these three lines, but this will fail in some particular test cases. Okay, let's say we have just one test case with three elements, and those elements are okay. Three is a bit too small. Let's say we have one test case which has five elements, not percentage elements. Yeah, we have one test case which has five elements, and the elements are 3, 2, 1. Then a dip, 5, 4. Answer turns out to be 26. Let's manually calculate the DP table. Yes, at this point, we are just testing. Okay, let me add back this line. The answer was 26 earlier, but now I suspect the answer will change. So, yeah, five elements 3, 2, 1, 5, 4. Shit. Shit. Okay. I messed up. I messed up here. Even in this thing, I messed up. What we have to do is I plus 1 minus LDSI. I plus 1 total elements onto the left, including the current element. and minus LDSI. That is the longest increasing subsequence here. Shit, shit. This is wrong. This will give wrong answer. This is wrong. Yes. Shit, this is wrong. Mm, this part is correct. This part is actually like easy to handle. But this part, we have to figure out what exactly we are adding to our current element, to our current DPI, and this dip. I think we have to keep one extra. Oh, shit. Shit. Okay. We have to keep one extra bit of information with us, which would be where does that longest in decreasing segment onto the left ends or begins. Ends would be a nice thing to know. Shit, yes. And shit, okay. Before that, I have to go to the washroom. I'll be right back in just 1 minute. I'm back. Where does the longest decreasing subsequence ends? We are very close to the right answer here. Like we have spent like 1 hour, but that is okay. And it's also we are getting right answer here. But if I were to submit this, we will get wrong answer. Let me just be sure for sanity check. Yeah, I suspect, yeah, this will give wrong answer. This must, yeah, this will give wrong answer. This will give wrong answer. Yeah, wrong answer. Makes sense. Because this part, in this part, we do not know how much further are we going to extend this. Yes. Is how much further are we going to extend this? Yes, share. Yes. We don't specifically know. I guess, yeah, everything is fine. Cool. We need some more information. Index of LLDS psi would be n, and this whole thing equals 1, and index of LLDS 0 equals 0, which we like didn't even have to say because everything by default is 0. Okay. And here, if you're not extending anything, then index of LLDS I equals index LLDS I minus 1, right? And here also we want to update the thing, but before updating we have to, yes, we know here that we are extending the previous thing, and if LLDS LDS I LDS I single L LDS I is greater than or equal to LLDS I. Shit, there might be multiple segments with the same decreasing length. So how far are you going to go? To that one or to this one? The first one, the first one. The last one. This should this be equal to or not? That is the question. And longest decreasing subsequence ending longest decreasing segment ending at I, if that is higher than, first of all we can update LLDS I would be equal to LDS I, but how do we update the index? And else if that is not the case, if that is not the case, then LLDS I equals LLDS I minus 1, and also index of LLDS I equals index of LLDS I minus 1. And shit, not just this. Okay. The thing is, does this has to be equal to or not? Okay, equal to. Yes, there has to be equal to. There has to be equal to. Equal to makes so much. Yeah, equal to makes sense. Equal to makes sense there. After updating this, in this part, if uh, should that is like exactly what we were checking above there. So okay, and we can skip this. We can put this part here, and we can add this here. A LDSI longest decreasing segment ending at I if greater than or equal to longest decreasing subsequent at I minus 1. If this is the case, then LLDSI index I DP I plus 1 I plus 1 I plus 1. Okay, yes. But if smaller, if small, then LLDSI minus 1 index I minus 1 index I minus 1 DPI. Yes, this is the part that we have to now figure out how much do we add to the DP. Yes, and to approach this thing visually, which should be the right way for things, but we are like actually very close to this. Yes, we are saying that whatever the longest decreasing subsequence was till now, it is nothing compared to what we have got here, right? So this is I and this is I minus 5. And for I, there were a bunch of segments, right? We had the answer for all the segments still here. And here, a bunch of these segments need to be extended towards the right by one element. And our whole problem is just to figure out how many of these segments are going to be extended. Right? Let's say this was the longest one till now. And we have the index where this thing ends, like where this thing ends. And we know that we are saying shit that this one is longer than this one. Okay, if this one is longer than this one, then when is the part when this one starts to be longer than this one? That would be, let's say the length of this is x inclusive. This is included and this is also included, which is LDS, LDSI. Length of this thing is x, which is also LDSI. And the length of this thing is LLDSI. And the index is also, we know what the index is. And here LLDSI is including both of these things. So we need to know the index of the element for which this segment equals this. Index. If we reduce index by 2, shit, I minus minus LDSI I is the number of segments on the left, the total number of segments on the left, that is I. And this part is the total number of segments on the left, the total number of segments on the left for which LDS I is not the longest decreasing subsequence. So this part gives us on the left the total number of segments for which LDSI is the longest decreasing subsequence. So we are extending all of them by one, and also we are adding one because our current element itself is one of the subsegments. Okay, if this works, this is working here. This is working here. If we don't know about here, okay. Yeah, it doesn't work. Hello, how is everything going on? I hope better than this. Wrong answer on test 2. Is there something else that I'm missing? Or I think, yeah, maybe I should take a break and then come back to this maybe tomorrow. 43rd number, expected 48, found a smaller number. Plus. Expected a higher number but found a smaller number. We are very close to solving this, but okay, I guess we can take little, a little break now, and that would be it. Yep, for today, that would be it. And thank you for being here. We did quite a few questions, actually, 1700 rated question, which is cool. And that would be it. Thank you for being here. Bye.